Hey guys, in this video we will test full capacity for this lithium iron phosphate battery bank. I assembled this battery bank about 2 months back, and configuration for this lithium iron phosphate battery is 3 cells in parallel, 16 cells in a series. And when I was assembling this bank, I used new 155 amp hours cells. So with white negative terminal is 155 amp hour cell, and with yellow negative terminal, this is cells which I'm using about 8 months, and this is 150 amp hours cell. So total capacity for this battery bank is about 23.5 kilowatt hours. Right now I'm charging this bank with my solar system at about 2.5 kilowatts, and right now we're at 55.1 volts, and I'm gonna wait till this fully charged from solar, and then we will start performing capacity test. Also, I would like to answer a few follow-up questions for this bank that you asked in the previous video. First question was asked a lot about cells positions. Right now they lay down on the side, and before assembling this pack I checked with the seller and manufacturer. In my case I bought these cells from BLS, and they asked me if this cells is going to be moving or installed in a vehicle, but then when I said it's going to be static, installed in the garage, they said it's okay to install cells like that. Second question was asked a lot about overheating. When I was assembling this battery bank, I used this kind of insulation on the back side for this cabinet, so when cells is gonna be moving, it's not gonna hit metal cabinet on the back. Also, when I'm closing these doors, I'm installing same material here just to protect front terminals. So in my case, I don't have any ventilation, and I'm using this pack with maximum charge and discharge rating as 0.15C. So that means these cells will not overheat because of high amps discharge or charge. If you're planning to draw 2C rating or even 1C rating from your battery pack, it's recommended to do ventilation here. In my case, I just don't need it. Cost for this project. In my case, I paid $7,000 total cost for this project. This is including cells, metal cabinet, all wires, BMS, active balancer. I have fuse installed there, and this switch. So total cost $7,000. As of today, it could be about 30–40% cheaper, because you can find on AliExpress 280 amp hours cells, which is really cheap. You can buy 32 cells and build 2 parallel 16S configuration, and it's going to be cheaper than this pack, and it's going to be more power. I will leave link for these 280 amp hours cells in the description. Now let's move to equipment that we're going to use for testing. So on the DC side, I'm going to use this monitor. We'll run wire through this sensor, and we'll see total capacity for this battery bank. Also, to draw power, I'm going to use this 48 volts 2 kilowatts inverter. I'm going to use electric space heater. And before we start capacity test, please spend 1 second and click this like button. It helps me a lot. Also consider subscribing to this channel. On this channel we're building battery bank like that. We're reviewing solar systems like charge controllers, solar inverters, BMS, active balancer. We're reviewing a lot of stuff here. So if you like content for this channel, consider subscribing. And right now, let's wait till this bank fully charged, and we will start capacity test. Alright, so cell pack is fully charged. Right now we're at 57.6 volts. Cell voltage, highest cell voltage 361, lowest 357. This meter connected, inverter connected, negative directly to battery bank, and positive connected to relay. Right there, yellow relay. So charger, this kind of BMS controlling charge and discharge using relays. So it will shut down load when cell will reach, let's see, what is the settings? when cell will reach 2.8 volts. So I'm going to discharge till first cell will drop 2.8 volts. Alright, let's turn inverter. Alright. And turn in heater. And we draw 1.4 kilowatts on the AC side, and we draw about 29 amps from DC side. Right now it's 10 p.m. so I will come back here in the morning and we will see the results, how many amps, how many watt hours we're gonna get from this pack. So next day, next morning, we're running this test for 10 hours 6 minutes. We're still drawing 1.5 kilowatts. Total withdrawal from pack 15 kilowatt hours from DC side. On AC side we draw 13.9 kilowatt hours. Let's see where we are with the numbers on BMS. So cell pack voltage is 51.67, then cell temperature 15.616, alright, so I guess it's gonna take about 8 to 7 hours more to draw this battery bank. My solar is disconnected, so I have this charge off. And here's the middle result. Here's one more result a few hours later. So we're running this test 14 hours 21 minutes. We draw 131 amp hours from battery bank, voltage 49.9 volts. On the AC side we used 19.72 kilowatt hours. And let's see where we're with the battery. So lowest cell is almost 3.1 volts. Let's come back in a few hours and see where we are. Okay, so we're moving to the final result. BMS will shut down load in a second. We're reaching 2.8 volts. Yep. So BMS just turned off a relay right there. And let's see where we are with results. So we've got 457 amp hours, 23 kilowatts of energy, and test was running 15 hours 12 minutes. For AC side, so for AC side we draw almost 21 kilowatt hours, but again this number is just to calculate efficiency for this inverter. For these cells we can discharge this to 2.5 volts. I don't want to go in such low voltage, so I'm gonna stay with 2.8. And also remember that I have BMS and active balancer connected to this battery pack. And also I have this relay which is draw about 20 watts. So we can calculate like 20 watts for a relay, and let's do 5 watts for active balancer, 5 watts for BMS. So we've got 30 watts, and multiply this by 15 hours. We can calculate how much energy we need just to maintain this pack healthy. Alright guys, that was quick test, not a quick but 15 hours test for usable capacity for this battery bank. Again, please support this channel by simply press like button and leave comment. And if you like content on this channel, consider subscribing. And as always, thank you for watching and see you later.